Hey, Monster Man, awesome work so far. This is Bruno. Hey, listen, great work on the last project, but we have another client and they need this ASAP. We have a hospital with a ton of patient records and they have no idea how to use Excel. They don't really understand all what the numbers mean. We need something visual for them to understand and predict whether a patient might have heart disease or might get heart disease or not. So here's some data. I need you to visualize it for me and make it look pretty so that we can present it to the hospital. You're cool with that, right? All right, great. I heard this library Matplotlib is going to do the job. Oh, by the way, the clients really like the color blue, so make sure the visualizations are in blue. I know, kind of a weird request, but hey, they pay us the money. We got to do what they say. All right, everybody, it's time to learn about data visualization. Now, this is a really fun topic because we get to make pretty visualizations, pretty charts to understand data better. But keep in mind that data visualization is one of those tricky things where it might be really easy to create something visual, but the most important part is to create something that's actually meaningful. It's very easy to do data visualization wrong, to present a graph that is misleading, a graph that is not accurate. When it comes to data visualization, we have to make sure that what we represent visually is accurate, precise, and is meaningful. That's our job. A data scientist turns data that is useless to data that is useful. And data visualization is a big part of that. So let's get started.
Alrighty then. So in the past few sections, we've been looking at data in the form of lists of numbers and arrays and data frames. But in this section, we're going to start looking into Matplotlib. And so the first question you may have, and it's a fairly good question to have, is what is Matplotlib? Well, as you might have inferred by the name, it's a plotting library, more specifically a Python plotting library. So it'll fit in with what we've been using before. And what Matplotlib does is it allows us to turn our data into some pretty visualizations, also known as plots or figures. So let's get started. If we refer back to our machine learning modeling framework, we go through problem definition, data, evaluation, features, modeling, experiments. Then if we go back to where our tools fit in, we're going to be covering Matplotlib, which is a part of the data analysis section, but can also, as you'll see with all of these tools, can also be part of the experiment section. We'll get to that in a future video, don't you worry. But this is going to complete the trifecta of Pandas, Numpy, and Matplotlib. And once you start to see these three in action, it really makes sense the synergy these three provide in doing data analysis and exploring different data sets. So why Matplotlib? Well, first of all, it's built on Numpy arrays and Python. As we've discussed before, a lot of data and numerical information are built upon Numpy arrays, including Pandas Data Frames, and it's the same with Matplotlib. And because all of this is written in Python, we won't have to learn another coding language. So now we can work with our data and create visualizations, as you'll see shortly, with the same coding language. It integrates directly with Pandas through the Matplotlib Pandas Api. You can create basic or advanced plots. And again, like the other libraries, right? Matplotlib, if you can imagine a visualization, if you can imagine a plot, you can probably create it using Matplotlib, but we're going to be focused on the most useful types of plots. And it has a simple to use interface, of course, once you get the foundations, but that's what we'll be covering. What are we going to cover? Well, there's a little bit of a workflow that happens within Matplotlib. You start with the data. You create a plot, also known as a figure, which is kind of just like an empty square, really. And then number 3 is you plot data, axes on figure. So they're the two main data classes of Matplotlib, axis and figure, but we'll look into these shortly. And so once you've plotted some data, you'll have something that looks like this, an X and a Y axis with some information on here. Then you can customize the plot and add in something like a little bit of a title here, and another title here, and a title here. So in this case, we've got the zero to mastery machine learning, and over time, your ML knowledge is increasing. Well, that sounds great. That's kind of similar to what we're doing now. And then finally, you'll save or share the plot. because as you could imagine, looking at a big table of data full of numbers, they can get quite confusing. Humans, we're visual creatures, right? We want to see things visually. So that's where these plots come in handy. So you can save or share them to visually communicate your work rather than just having it in a table full of numbers. So more specifically, once we've gone through the Matplotlib workflow, we're going to use that workflow throughout all of these little dot points here. We'll focus on importing Matplotlib and see the two different ways of plotting. Yeah, I know, there's two different ways, but we're going to look at them both, and then we're going to pick the one that is most useful and most adaptable. We're going to plot data directly from Numpy arrays, so that'll build upon the Numpy section. And then we'll look at how Matplotlib integrates directly with Pandas Data Frames through the Matplotlib Pandas Api. And we'll have a look at customizing our plots, so adding a different color, putting in some different titles, naming our things what we want. And then finally, we'll finish up the workflow by saving and sharing our plots so we can communicate our work with others. Now, where can you get help? The first step is to always follow along with the code if you can. Remember our motto, if in doubt, run the code. So we'll be going again through another Jupyter notebook. It'll be available for you to go through at the end of the session or in the extra information section. Always try it for yourself. If in doubt, run the code, try another thing, keep going. If you're still stuck, search for it. You'll probably come up against Stack Overflow. We've seen that in the past. Or the Matplotlib documentation, which again is very vast. So if you have a specific problem, you might try search for it first and then read through the documentation if you don't really understand what's on Stack Overflow. Try again, and then finally ask a question. Remember, if in doubt, run the code. I have to keep reminding myself of this too, you know. All right, well, if you're ready to plot, give me a wave. Yeah, I'll stop with the jokes now. I'll see you in the next video. So let's get started with Matplotlib. We're going to start on the desktop and do what we always do and hit the terminal. Beautiful. I'll zoom in a little bit on here. Excellent. Now we're going to go through our little workflow like we always do. So we're going to CD, for me, I'm going to get into the sample project folder, which contains our environment. Remember, we can always see our environment by using conda env list. So this will show me my environments. This is the one I'm after here, sample project, the folder we've been working through before. So I'm going to CD, I'm on the desktop right now. We can see that there. So I'll go into ML course. We can see that little folder up here, but we're going to use the command line. And then CD again into sample project. Beautiful. And then we can run conda activate. Now you could just copy and paste this and do that there. But remember, we're in the habit of typing out code. That's the best habit you can develop. That way you get used to writing things out for yourself and practicing, seeing what it feels like on your fingers to write code. So if we go conda activate, that should be all correct. Wonderful. And so we've had base change from this to this. We've seen all this before. We're going to load up a Jupyter notebook, our favorite workspace. We've got Introduction to Numpy and Pandas. We've been through those. We're going to start a new one. So now we're going to retitle this one to be Introduction to Matplotlib. Beautiful. We'll have a title, Introduction to Matplotlib, just so we know what's going on. We're in the habit of communicating what we're doing. There we go. Beautiful. And so now we're in a Jupyter notebook. The first step for always using Matplotlib is we might import Numpy and Pandas as well. So we'll import all the tools we need right at the top of the notebook. This is kind of a regular workflow. So the first one we'll do is Matplotlib inline. Now, if you've never seen this before, this little percentage sign you might have in a previous video, but this is a magic command. So this percentage sign is telling Jupyter, hey, we want all of our Matplotlib plots, our graphs and visualizations to appear within the notebook. So that'll make more sense once we run it. So let's import matplotlib.pyplot. Now pyplot is a Python plotting module of Matplotlib, and the convenient name is as PLT. We'll also get pandas as PD and import numpy as NP. Then we'll hit Shift Enter. This might take a little while depending on what's going on. Beautiful. So now we should have all these tools accessible. Now, simplest way to create a plot in Matplotlib is with plt.plot. So if we go Shift Tab, have a look at what this says. Plot X versus Y as lines and or markers. What happens if we just run this? Okay. We get kind of that empty box that we saw before. That was in the Matplotlib workflow. So this is our create a plot. This is our figure that we've just created. So we'll go back to our Jupyter notebook. This is our figure that we've just created. But for some reason, the output, it's giving us these empty brackets. So to get rid of those, you can put a semicolon at the end of your plot call. So let's do that. Same thing, we just don't have that nasty little output there. This is what Matplotlib inline means, is that this plot is in the notebook, so we can see it visually right here. That's all Matplotlib inline means. If we didn't call this, it would just output something like this with no plot. So that's what this line of code is doing. So it's an ideal scenario to always run that when you want to run Matplotlib plots. And now, if we didn't want to use the semicolon, if we wanted to be a bit more communicative, we could go plot and then plt.show. That's going to do the exact same thing. We've got a nice and blank plot here. Now, how about we add some data? So we go plt.plot and then hit Shift Tab. Plot X versus Y as lines and or markers. And if we click the plus sign, it gives us a little example here of plot X, Y. So how about we pass it X as a list of some sort. So maybe we'll just keep it nice and simple. 1, 2, 3, 4. And we'll put the semicolon at the end and see what happens. There we go. We've got a line. And so this is on the X-axis. We should have 1, 2, 3, 4. Okay, beautiful. So what can we try next? Well, let's create some X and Y data. X, 1, 2, 3, 4. Wonderful. Y equals, let's mix it up a little bit. 11, 22, 33, 44. Wonderful. Now let's see what these look like. Plot.plot, X, Y. And we'll put a semicolon at the end. There we go. We notice that our axes have changed. So now we've got from 1 to 4 on the X and from 11 to 44 on the Y. Okay, that's starting to make a bit more sense. This is looking good. Now, this way of plotting in Matplotlib is referred to as the stateless way of plotting. And if you've ever used MATLAB, it works like that. But if you haven't used MATLAB before, not to worry. Let's have a quick look at Matplotlib Documentation. Because in there, it tells us a little bit about different types of plotting in Matplotlib. What do we want? Documentation, tutorials, PyPlot tutorial. So this is the type of plotting that we're using at the moment. We've got Matplotlib. PyPlot is a collection of command-style functions that make Matplotlib work like MATLAB. Yeah, that's what we just went through. Each PyPlot function makes some change to a figure, creates a figure. So I've been calling these plots. They're also referred to as figures. Creates a plotting area in the figure, plots some lines in a plotting area, decorates the plot with labels, etc. In matplotlib.pyplot, various states are preserved across function calls. Okay, we're just reading the documentation here. So this is the one we're paying attention to. Note, the PyPlot API is generally less flexible than the object-orientated API. So remember how I said there's two ways of plotting in Matplotlib? Well, we've just looked at the PyPlot API, and we're going to look at the object-orientated API in a second, but this is the one we're going to be focused on most, the object-orientated API, because we want as much flexibility as we can get, right? There's one more thing I want to show you. So if we go Matplotlib lifecycle plot, the life cycle of a plot, there we go. And you can get to this in the documentation as well. So this is just matplotlib.org, tutorials, life cycle of a plot. There we go. This says the same thing. In general, try to use the object-orientated interface over the PyPlot interface. Okay, so if the documentation is saying these two things in bold notes, we might listen to it, all right? Because the people who write these documentation, they really know what they're doing. So let's see. This is the first method. We'll go fig equals, now fig is short for figure, plt.figure. This creates a figure. Ax is short for axes. So remember, this whole thing is a figure, but these two lines here are axes. So ax equals fig.add subplot. This adds some axes. Plot.show. There we go. So this is just replicated exactly what we did. We did like a kind of a long version of going plt.plot. Same sort of thing here, right? So this is the first method. And then we've got the second method. So we want fig equals plot plt. And when I say plot, I'm referring to plt, but because there's no O, it's just easier for me to say plot. So creates a figure. We're being communicative here. You don't need these comments. Ax equals fig.add axes. And then within here, we're going to add some sample data, 1111. Oh, sorry, these are going to add axes. So these add axes to the figure. So there we go. We've got another figure. If we want ax.plot, let's get our x and y on there. And then plt.show. Add some data. There we go. We're just creating the same plot. And now finally, we're going to go with the third method. And this is the one that we're going to be using. So we'll put in here recommended. The reason why I'm showing you all these is because if you look up Matplotlib online and you find some documentation or some Stack Overflow answers, you might come across these styles of plotting. So we're going to use a third method. Now this is recommended. Of course, you can choose your own, but this is what we're going to be going through throughout the rest of the Matplotlib section. So this is fig, ax this time. So we've saved a line of code equals plt.subplots. Now let's see what this says. Subplots. Create a figure and a set of subplots. This utility wrapper makes it convenient to create common layouts of subplots, including the enclosing figure object in a single call. Now, what is a subplot? You can think of a subplot as having more than one plot come out at the same time. That's all it really is. And then we're going to go ax.plot x, y. Add some data. And we'll put a little semicolon at the end instead of calling plot.show this time. There we go. We've just recreated the same graph 3 times with 3 different methods. But we're going to be focused on the third method. And you might notice that every time I call something like fig equals or ax equals or fig ax equals, it resets the figure. Even though we're plotting the same data, maybe if we went here and we go 50, 100, 200, 250, it's going to change it up. So every time we call something like this, it's going to reset the figure and plot a new set of data. So let's wrap it up there. But in short, the main takeaway from this lecture is that we're going to be focused on this method. There's 2 different types of methods plotting in Matplotlib. The PyPlot API, but that's generally less flexible. It is quicker to get plots up and running sometimes, but the object-oriented API is going to allow us to do a bit more fancy stuff in the future, so that's what we'll focus on. I'll see you in the next video. Welcome back. In the last video, we checked out a few different methods of creating Matplotlib plots and figures. That name is kind of interchangeable, same with the name visualization. If you hear that, they're often referring to the same thing. And we looked at a little trick with the little percentage sign to set up Matplotlib so that our plots appear in our Jupyter notebooks. So now, we're going to start this video off by checking out the Matplotlib anatomy of a figure. So let's have a look. As I just said, I've got anatomy of a Matplotlib plot, and I just said we're going to check out the anatomy of a figure. So this is how I mean these words are very interchangeable. So I want you to be aware of that whenever you're looking at Matplotlib online. If you're going to Stack Overflow or whatever resource, the documentation probably is more formal using the word figure. We'll see that in a moment, but if it refers to plot or visualization, they're always meaning kind of the same thing, which is this complicated but beautiful mess here. So if we look at it, figure is kind of like the giant section here. everything, the blue square. So the figure contains all of it. It's like the blank canvas. And then what we're going to do is start to add things as we go to make our plots look beautiful. So we've got some data here. This is heart disease analysis. This is the centered title. Don't worry if this looks a little bit more complicated than the plot we've just done. Like, this is a very simple plot here. This one's got a bit of fancy colors and a horizontal line and titles and legends. We're going to work towards making something like this by the end of the section, so we'll get there in a moment. But you can see here, these two axes, this is a subplot. We've got one plot here, axis 0, and this is axis 1. So there's two types of information here, but they share an x-axis, which is the age. We've got an x-axis label here. We've got axis 1 title. This one's got a legend. So does this. And then we've got two different y-axis labels. So this one is max heart rate, and this one is cholesterol. And then we've got a mean line going through here. You might want to take a screenshot of this, but don't worry, it'll be in the resources section. This is kind of the anatomy of most Matplotlib plots that you'll check out, at least for 2D plots anyway. So yeah, you've got label titles, and what all these little things do is that they just add to the communication value. Of course, you could make a plot without these titles or these horizontal lines or these fancy colors, but it would be kind of hard to understand, so that's why we add these things here. Let's go back. Before we jump into the next video, let's have a little bit of a look where the object-oriented comes from. So if we go back to this cell here, we might go type fig, type ax. So here we go. We've got matplotlib.figure.figure. So the formal definition for something like this is a figure. And then we have matplotlib.axes.subplots.axes_subplot. So this is what it means when Matplotlib talks about the object-oriented API. So we've got the figure object, which is back to our anatomy. This is the figure object here, this big blue square. And then we have the axes objects. And now the axes objects, they're always kind of a subplot because this is a subplot on a figure. But you can have more than one axis on a figure, if that makes sense. So if we had two more of these over here, this blue box would stretch out to cover those. So the figure is the base canvas, and the axes are like we're drawing on that base canvas. Now that we've kind of understood the fundamentals of Matplotlib with the figure and the axes, let's check out a workflow in its entirety. So we'll type in here, Matplotlib example workflow. Maybe I'll make this a heading so it's a little bit separate. Matplotlib example workflow. So step 0 is import Matplotlib and get it ready for plotting in Jupyter. Beautiful. Now we've already done this, but I would just want to do it all in one cell so you can see it happening. Matplotlib inline, import matplotlib.pyplot as plt. Step 1 is to prepare some data. Prepare data, x equals, we'll keep it nice and simple just as we did before, but you'll see in reality, x and y can be basically any data or any numbers that you can imagine. And then we go number 3. We're getting ahead of ourselves here. Set up plot. Now this is where we use the object-orientated method. Fig ax equals plt.subplots. We're going to throw in a little keyword here that I want to introduce you because you'll see this a lot. Fig size 10, 10. Now let's see what this means. Can we go Shift Tab? Yes, we can. We go down. Is it going to have it there? Oh, it might not. Fig size parameters. We'll keep scrolling through here. It's a bit hard to see. Fig size, ax, examples. Well, I'll just tell you what it is. Or you can practice looking up the documentation. But what this essentially means is it's just height and width. And they may be back to front. It's usually x then y, so this is probably width and this is probably height. That just means the dimensions of this plot. So we'll go here. And we'll go number 3, which is plot the data. So we want to add to our ax, x and y. What have we done here? We've created a figure and we've created an axis. And now what we're doing is adding data to our axes. Okay, yep, this is making sense. And then we want to customize plot. Now, we haven't seen these, but they're fairly intuitive. So I'll let you guess as I'm typing them out. Simple plot, that's a good title, I think, what they actually mean. So now that we've done just one, what do you think we've got? So we've got ax.set and then a parameter saying title equals simple plot. X-axis, we'll keep the titles for the X and Y. Nice and simple. Y equals Y-axis. Wonderful. And then we'll go number 5. You probably wouldn't usually do this. I'm just showing you all this in one hit just for the sake of seeing a Matplotlib workflow running live. Save the whole figure. That's the word I'm looking for. That's what I said out loud, but that's what I didn't type. So fig.save fig. And then we want to save it to, I've got an images folder set up that I already have prepared earlier, so you can save it wherever you want, but this is just going to be the path name, sampleplot.png. There we go. So let's step through this. We import Matplotlib. We tell Jupyter that we want to plot our Matplotlib plots inline or figures inline, so within the notebook. We've created some data, X and Y. We've set up a plot, aka a figure. We've given it a size of 10 by 10. We've added some data to the plot on our axis. And then we've customized the plot. Now, can you guess what's going to happen here? If we look at this, then if we compare it to our anatomy, we've got a title and we've got X and Y labels. Can you guess what this is going to do here? We'll see it in a sec. Remember, if in doubt, run the code. And then we're going to save a figure here. We could share it out like that. Let's see what this does. Ah, we got an error. That's all right. No such directory. That's all right. I thought I knew the path of my image directory. Doesn't really matter. Images. What have I got wrong? Images. Oh, I don't think I need the dots. There we go. Simple plot. So this is a 10 by 10 figure. So let's practice this. Maybe we change this to 5. Okay, yeah, so that was width. So this is width, height. Beautiful. There we go. Well, that's not looking very good. So let's put that back to 10. Wonderful. And so now we can see the title is simple plot. The Y label is Y-axis and the X label is X-axis. Of course, if you had some data on here that was more specific, you might want to label your X and Y axes to tailored to your data. But in our case, this is just a nice and simple plot as we've got the title here. And if we go back up here, check in our images folder, we've got sampleplot.png, which if you didn't want to write this line of code, you can also right click and go save image as. But that is enough. You've seen a Matplotlib workflow. You've also seen the anatomy of a Matplotlib plot or figure. So before the next video, try to create your own plot like this. Get as fancy as you like. Create a little bit of data. You could try create a Numpy array and plot it and see how you go. Otherwise, I'll see you soon. In the Numpy section, we talked about how many Python data science packages are built off Numpy arrays. The same goes for Matplotlib. And one of the beautiful things about Matplotlib is it's about as flexible as Numpy arrays. If you can dream up a way to visualize data, chances are you can do it in Matplotlib. But there are some common kinds of visualizations than others, or some more common, ones you're more likely to come across. And these plots are the ones like line, scatter, bar, hist, and subplots, or plotting multiple visualizations on one figure. Let's have a look at some of these kinds of plots that you'll see more often, plots or figures, remember that word's kind of interchangeable, using pure Numpy arrays. So we'll start it off. So we'll go making figures with Numpy arrays. We'll make this markdown so it's a little bit communicative, and then we'll go import. If you haven't already done this, we've done this at the top, but we'll do it again. Import NumPy as NP. And we'll start off by create some data. X equals np.linspace 0, 10, 100. Might be going, hold on, Daniel, we haven't seen linspace. Well, in that case, remember, what can you do? Did you get it? Well, if you didn't, doesn't matter. We can press Shift-Tab and see what linspace actually does. So we want np, linspace, yep, start, stop, num. Okay, so they're the first 3 arguments. We've got 0 as start, 10 as stop, 100 as num. All right, well, let's have a look. return evenly spaced numbers over a specified interval. Returns num evenly spaced samples calculated over the interval start stop. So it's going to return num evenly spaced intervals between start and stop. So what do you think will happen here? Well, if in doubt, run the code. Let's check it out. Well, there's going to be 100 samples, so we don't want to see all that. Let's see the first 10. Wonderful. Well, let's see the first 100. Why not? I'm into taking risks, aren't you? So there we go. We've got 100 different samples here, 100 different floats values here between 0 and 10. So we start at 0, goes all the way up to 10. Wonderful. We'll reduce this back to 10 to save some space. Excellent. Now, let's go plot the data. So remember, we're going to create a fig and an ax, or figure and axes. But these are the common short names for figure and axes. We'll go plot.subplots, because this is the method that we're going to be using. We'll go ax.plot, x, and let's do, because plot takes x and y, but we don't have a y, let's just do x to the power of 2. Well, let's see what happens. We'll put a little semicolon. Wonderful, we get this beautiful curved line. So the default here in Matplotlib when you call plot is a line plot. This is a line plot. So, and create a line plot. There we go. So as you can see, just a straight line. Now, use the same data. Let's create a scatter plot. Use the same data because these are the most common types. Let's write these down. We want line plot, scatter plot, bar plot, hist, and hist is short for histogram, and a subplot. They're the main types of plots we're going to be focused on. Of course there are more, but we could be going all year for the amount of plots you could do in Matplotlib. So we'll focus on the baseline ones, and then you can build upon that knowledge. So we want use same data to make a scatter plot. We'll see what a scatter plot is. So if we want to recreate it, we have to always reset fig and ax. If we're in a different cell, equals plt.subplots. Wonderful. Ax. Now we're going to use scatter. So up here we use .plot, but if we want a scatter plot, we'll see what that looks like in a second. We need to call .scatter on ax. So here we go. We want x, and then we want np. Maybe we'll do the exponential of x. And remember, if you're not sure what exp means, you can go Shift-Tab, read the doc string here, what it says it is, and if it's still not clear, you can look up the documentation. There we go. Well, it's kind of like a line, but a scatter plot is just another word for lots of dots on the plot. These are really close together, these dots, so they kind of look like a line, but they are all just dots. All right, well, how about another scatter plot? Let's make another one, just so we can see. Fig, ax, I want you to get really used to typing out this. Fig, ax, plt.subplots. This is going to be our bread and butter for Matplotlib. Ax.scatter, x. Let's create a wave, because we did one of those before, and that was my joke. Beautiful. So we got a nice little wave here, and if you're not sure what this is, well, this is a sine wave. And again, you can always see the doc string, or look it up. Remember the steps, you can search it up if you're still not sure after looking that. We've been using NumPy arrays, and that's what this section is, making figures with NumPy arrays. How about we create a plot directly from a dictionary? So, make a plot from dictionary, because this is just showing how versatile and flexible Matplotlib is. So if we want my almond butter store, we'll bring that back. So we want nut butter prices. That's my favorite food. Do you like it? I like it too. So we want here, almond butter, 10. It's quite expensive. Peanut butter, not as expensive where I live. So 8. And cashew butter is the most expensive. Cashews are hard to come by, you know. In short supply sometimes. So if we go here, and then if we want fig, ax, equals plt.subplots. We're getting really good at this one. And now we want, let's do a bar plot this time. So you notice the trend? We're changing this. Now I know it's kind of confusing because this is a line plot, but it says plot, doesn't say line. You're just going to have to get used to the fact that the default Matplotlib is a line plot. But now we're going to create a bar plot. So ax.bar. And we're going to pass it x and y. So our x, maybe we'll be a bit more formal. X equals nut butter prices. What do we want? We want the keys from our dictionary, because we're using a dictionary now, not NumPy array. So we want the keys here. And our y value, so we'll type in y. That's what plot or bar or scatter always take. X and y. Might put that in a little comment. X, y. Nut butter prices dot values. Beautiful. And now we might see what this looks like. Ah, error. Missing argument. Height. That's interesting. I see this. This one doesn't take y. That's a problem. Positional argument keyword found. What if we get rid of this? My bad. This doesn't take x and y. See? You're learning something new every day. Shift tab, x. Oh, well, that is x. X equals that. That's what we can't have. We can't have that equaling that. So we're going to leave this at that. Ax.bar, shift tab. So this is a little Python thing. If you haven't seen this before, it's a syntax error where in a Python method, if you have a positional argument, say x equals this, you need something after it to go like, say, y equals this. You can't have x equals something and then followed by that. But you can have it the other way around. So see how we don't have x equals? We can have this being height equals. It'll come out with the same thing. So the first one can't have a positional argument, where the second one doesn't, but the second one can, and the first one doesn't have to. That's a little bit of a Python tidbit there. So we're getting a lot of value from this Matplotlib lecture here. Now, this doesn't really make sense. We've got a few bars here. You could kind of infer that that's prices. Let's customize it. Let's add a little bit of a title. We want Dan's Nut Butter Prices Store. And see, that little exploration that we just did before, that's going to happen, right? You're going to make mistakes. You're going to think you know things like me. And then you're going to go, oh, that's actually not like that. And then you'll look at the doc string, you'll fix it up, and you'll combine your previous knowledge and go, oh, that's why that's like that. So don't worry if it happens to you. It happens to me. Y label equals price. But what we do is we strive forward and we figure things out. Shift enter. There we go. That looks a bit better. And what can we do to remove that ugly line of text there? I believe we can do ax.show. No, well, that has no attribute called show. But we can add a semicolon up here, I believe. Or maybe down here. Yeah, okay, there we go. So we're learning on the fly here. If you want to remove that nasty line of output code, you can add a semicolon to the last line where you call ax. We've seen this semicolon before, but we've just seen where you actually have to put it. It's on the last line where you reference ax. Well, there we go. You can create your own store. We've just seen how to plot from NumPy arrays. We'll look at a little bit more in the next video, but to prevent this one from getting too long, we'll pause it here. So take a little break, create your own plot from a dictionary or a NumPy array, and I'll see you shortly. Welcome back. Hopefully you've created your own graph here out of a plot or figure. See, again, I'm mispronouncing all these different words. Hopefully your prices aren't cheaper because the nut butter game is very competitive these days. So in the last video, we finished off on bar graphs. There is actually a horizontal bar graph. You may have seen this before. So if we go fig ax equals plot.subplots, and we go ax.barh for horizontal, we're going to pass it just the exact same thing as above. Nut butter prices.keys and nut butter, because we've got our saved dictionary up there. Yours might be a different name. Dot values. Oh, what's happened here? Unhashable type. Dict.keys. I actually did look this one up. In this case, for the bar horizontal, we have to turn our values here into a list. Now, how did I find that? Well, I did our search method. I looked it up. I pre-baked it. I had to make sure that I was getting things right for this one since we messed up in the last lecture, but that's okay. So we go there. We got a horizontal bar. Same information, just presented horizontally. Now, which one should you use? It's more of a personal preference here. I like this one. It's vertical. Sometimes you'll want a horizontal bar. There are other plots that look better on a horizontal. We'll have a look at some of those in potentially a future video. Well, let's check out what have we done so far? We've done line, we've done scatter, we've done bar. Let's do histograms. What's a histogram? Well, let's see it first. Remember, if in doubt, run the code. We'll make some data. We'll go x equals np.random.randn, and we want 1,000. What does randn do? Shift tab. Return a sample or samples from the standard normal distribution. Now, what is a standard normal distribution? Let's have a look. Normal distribution. We'll go here. Okay. In probability theory, the normal or Gaussian distribution is a very common continuous probability distribution. Whoa, that was a bit of a mouthful. But what you really need to know is a normal distribution are these curves here. So in the middle here, this is the mean, and the distance between the mean and here is the variance. And so whenever someone refers to a normal distribution, they're referring to one of these kind of like symmetrical curves, and they can appear anywhere on the x-axis like this. That's what you need to know about a normal distribution. So if we go in here, this is going to make 1,000 random samples that would fit within this curve. But if in doubt, run the code. Let's actually see this in action. Fig ax equals, because remember, every time we want a new plot, we create a new plot. Subplots, ax.hist, x, little semicolon at the end. So what we've done here is we're doing a histogram, but oftentimes you'll see it shortened to hist. So if you see hist, probably referring to histogram. So if we do that, there we go. We've got a bumpy curve. It's not as smooth as this one, but you can kind of see it's got the same shape. That's what we're after. Just that same shape. Beautiful. Okay, now we've covered histograms. Now, what if you wanted to get multiple plots happening at the same time? We've referred to this before as subplots. Well, the beautiful thing is we can make them with the command we've been using. Now, again, there's two options for histograms, because we want to make this a bit more communicative and plot it. There we go. We're in the habit of being communicative, so we've got to finish off that cell before we start a new one. Two options for subplots. Let's do that. Make a little heading, and then we'll go subplot, option 1. Wonderful. Okay, we're going to create fig. Now this is going to look a bit different to what we've been doing. Ax1, Ax2, and you're like, whoa, what's going on here, Daniel? But don't worry. Follow along, and we'll explain it in a second, because remember, we're in the habit of just seeing what happens with the code. N rows equals 2. Hold on, we've never passed a keyword argument to this, and now we're going to pass 3. We're living dangerously, I told you. Fig size equals 10, 5. Well, my 5 key is a bit sticky, you know. So if we look, what is this actually doing? Let's run it. Whoa. Look at that. Now, can we infer what's happening here without even looking at the docstring? So we've got fig, comma, and then a tuple, which is of tuples of ax1, ax2, ax3, ax4. So can you guess what's happening here? And we've got some keyword arguments. N rows equals 2, n cols equals 2, fig size equals 10, 5. What do you think's happening? N rows equals 2, 2 rows, 2 columns. I've got ax1 maybe, ax2, ax3, ax4. Well, I think that would be pretty spot on if that's what you guessed. That's what I guessed. So here we go. Let's read. Create a figure and set of subplots. This utility, yep, we've read that before. N rows, number of rows, columns of the subplot grid. Beautiful. Now let's see, how would we get data on here? So let's do this. Plot to each different axis. Let's see this in action. Ax1, dot plot. Let's go x. We've got some x data, I think. That'll probably do. Let's see what happens when we do plot it. Boom. Straight line. Wonderful. We can do that. Okay. So yeah, Ax1 is this top left one. Okay, that makes sense because it comes first. Can you guess which one is Ax2? Well, let's see and find out. MP, let's make some more random data. Random.random. 10, and we'll do random.random again, 10, and semicolon. Ah, okay, and see we've created a little scatter here. So that's ax2, wonderful. ax3, let's do a bar on this one. We're going to start mixing this up, you know, nut butter. Can I do tab complete? Nut butter prices. Yes, I can. Dot keys, nut butter. We want the values on this one. Dot values. Wonderful. And let's see what happens. Beautiful. We're starting to fill out our subplot here. This is wonderful. ax.4, we want hist. And then we want mp.random.rand normal distribution. We checked that out before. There we go. Boom. Now we have a subplot with 4 different subplots. Now again, this is just some dummy data, except for this. This is real stuff right here. This is Dan's Almond Butter store. And now you could add some titles to these axes, much like we've done up here with this set command here. But this is just to exemplify one way, option 1, we'll do option 2 in a moment, maybe in the next video, of how you can get more information on the one figure. So if we look back to our anatomy, we go here, it's still a big figure. This blue square, if we converted this blue square, it's going to follow around this. But now we've got axis 0, axis 1, axis 3, axis 4. But it's actually axis 0, 1, 2, 3. But we've named them differently. In reality, we should have probably 0 indexed these, but I've just gone 1, 2, 3, 4. But now you're starting to see, if you wanted to get more information in just one image rather than having 4 different figures, you can see you can do that with subplots. The reason why we've been using this command is that you can create single plots or multiple plots with the same command. That's that flexibility we were talking about of the object-oriented API for Matplotlib. So this is option 1. Before the video gets too long, we'll pause it there and we'll have a look at option 2 in the next one. Okay, welcome back. So in the last video, we said that there were 2 options for subplots, but the beautiful thing is that we can use the same command we've been using for single plots to create subplots. So we've seen a preview of option 1. Let's do option 2, just because if you come across these, I want you to be aware of it. Option 2. In your research, you might see both of these come up. So that's why we're checking out 2 different ways. Do you have to use 2 different ways? No, you don't. We'll probably stick to using option 1 throughout the rest of the series. But this is just so you know what's going on. So go fig and ax. Oh, whoa. This syntax looks different already. This is just like we're making 1. But rest assured, we are creating subplots. And rows, so n cols equals 2. And then we want fig size. We're just replicating what's here. You could copy and paste and delete it, but again, remember, we're always in the habit of rewriting code. And we want here, plot to each different axis. Now, this is kind of the, I guess you could say the tuple way, and this is the list index way, this other option. Yeah, maybe we do that, each different index, to prevent confusing here. So we want ax 0, 0. Now, can you guess, before we even plot anything, what is this doing? So if I do this, fig ax equals plot.subplots, n rows equals 2, n cols equals 2. If we were to index into this ax for 0, 0, can you guess which one of these 4, because we're creating the same, this code here, and this code here does the same thing except for variable names. What are we going to plot to if we pass these index coordinates? 0, 0. Row 0, column 0. Well, let's see and find out. No cheeky reveals here unless we've run the code. There we go. Okay. So it's just the same as this here. But then if we go, let's do the same thing. So if we want 0, 1, we want to scatter. And we're just going to do the same random.random, I believe it was, 10, random.random. Wonderful. Boom. There we go. So again, these plots are different because it's random. So these scatter plots, same thing. Numbers between 0 and 10 or 1 and 10. But because we're calling different random ones, they're going to appear randomly. So each time we run this, probably have a different plot. There we go. But all this is saying is access row 0 and plot on column 1. So column 0, column 1. There we go. And so now you can probably guess what's going to happen next if we go 1 and 0 dot bar, and we want nut butter prices, beautiful. All this talk of nut butters is making me hungry. Might have to do that after this, nut butter prices. And that's the beautiful thing about owning a nut butter store, right? Is that you can just eat your own supply. Not too much though, because we need to still make profits. We're going to do two at the same time here. Hist, rand n. That's what I want. There we go. But you see what we've done? We've forgotten a semicolon there. And now, there we go. So we've created the same plot here, same subplot, using two different types. I personally prefer option 1, because it's a bit more readable for me if I look at something like this. You may prefer option 2. List indexing can be helpful in some scenarios. It's all about just trying it out and see how you go. But I think we'll stick with option 1 for the rest of Matplotlib section. So that's just to show the two different ways of doing subplots with the same command here, plt.subplots. All right. So now we've seen different ways of plotting directly from NumPy arrays, but it's most likely most of your plotting will probably take place from a Pandas data frame. So we've seen Pandas data frames in the past, and we know that they're built on top of NumPy arrays, and we know that Matplotlib plots are built on NumPy arrays. So let's see how this synergy works. I'll see you in the next video.
Hey, it's Andre here again with another quick note. Now, if you want, you can pause the video and read this little comic by XKCD. But I want to talk quickly about data visualizations. Now, we talked about this idea of exploring our data, right? And we can explore our data by looking at something like mean or variance or any statistical method to explore our data. But data visualization is another method we can use along with statistics to explore our data. So we often create these data visualizations like graphs to derive meaning from data. But it's easy to make graphs that are meaningless or misleading. And your job as a data scientist is not just to make pretty graphs and pretty visualizations, but to make visualizations that are actually meaningful and that are accurate. For example, axis is important. You need to know what the x-axis and y-axis is here. Otherwise, well, this graph is completely meaningless because we have no idea what it's measuring. This is a common mistake with beginners. That is, we assume that a graph is always telling the truth, and we jump to conclusions right away from data. Instead, we want to pause and reflect and make sure that whatever we're visualizing is accurate and testing it with different methods, trying different visualizations. We don't want to jump to conclusions right away from data. It takes a lot to understand this data. So, just a quick note, that is, just because we have data doesn't mean we have knowledge. All right, back to work.
Welcome back. So in the past few videos, we've looked at how to create plots like this. We've made some line figures, some scatter plots, some bar graphs, and some histograms. These are more than enough to get started plotting some of the most common things you want to plot in your machine learning and data science career. But more often than not, you're not going to be plotting directly from NumPy arrays. You're going to be plotting from Pandas data frames. And I guess you kind of are still plotting from NumPy arrays because Pandas is built on NumPy arrays. But that's what we're going to focus on in these next couple of videos, is plotting from Pandas data frames. So let's do that. Pandas data frames. Beautiful. So we're going to make that into a little heading using escape and pressing M. And now, first things first, we're going to import pandas because we need pandas to work with data frames. We've done this at the top of the notebook, but we're going to do it anyway just because we like that. And now we want make a data frame. Now we've got up in here, we've got our trusty car sales CSV, which we've seen before, which is just like a spreadsheet that's been exported into a comma separated value format, or .csv. So we've seen this in the pandas section. So we'll go car sales equals pd.readcsv. I believe it's called car sales. Car sales. You can always tab autocomplete here. There we go. That's helped us out. Thank you. We'll put a comma there and we go here, car sales. We'll check it out. Lovely. That's our trusty car sales data frame. Now, before we plot anything from here, let's practice looking up some documentation. Pandas data frame visualization. Wonderful. It already knows what I want to look up. It's almost like I've prepared this earlier. So, We want to look at visualization in Pandas. This is the Pandas documentation. We use the standard convention for referencing the Matplotlib API. Wonderful. So that means that Pandas builds upon Matplotlib. So what we want to do is, rather than reading through all of this documentation, because there's a lot of different plots, hey, there's a histogram. We've done some of these. So we'll go back up here. We're going to start off by just writing some code. And we're going to try and replicate this in some sort. So let's just copy this. And I know we're breaking the number one rule. Don't copy code, rewrite it. But we're going to rewrite it anyway. But I'm just putting it here. Create a new cell below, escape B, so we can copy it out. We don't have to keep going back and forth. You might see something in a Stack Overflow question or documentation, and you might just copy it straight from here, put it into your notebook, and then go, hey, I need this part, but I don't need this part, and just write out the parts that you actually need, right? But you never want to be just completely copying it. PD date range. This is a bit old, 2000, so we're going to upgrade it to where we are now. So 1/1/2020. Wonderful. A bit more closer to where we are now, actually. Periods equals 1000. Now, you might be going, okay, what does this mean? PD.dateRange. Well, remember our motto. If in doubt, run the code. So let's see this. TS. All right. So what's happening here? Well, we've got dates on the index. Yep, that makes sense. Index equals PD.dateRange. It starts at this date, 1st of the 1st, 2020, then goes up. So it's going up by days. Okay. And these are just random numbers being filled here in this column, going up. But what is cumsum? Well, let's type that in. ts.cumsum. What can we do? Shift tab. Return cumulative sum over a data frame or series axis. Cumulative sum. What does that mean? Well, let's find out. We run that. TS. Oh, actually, let's keep running. We don't want a negative there. What is happening here? This should be adding up. Maybe we go here. TS. This is interesting. This should be adding. TS equals that. I know what cumulative sum does, and it doesn't seem to be doing it here. What it's supposed to be doing is adding this one to this one, and then adding that one to this one, and then adding this one to this one. Oh, that's why. TS equals TS. Ah, classic. Daniel just trying to get ahead of himself and run the code. My own motto's letting me down. Let's see what happens. Okay. We got something kind of similar to this, but again, remember, it's always going to be different because we're using random.randn. Well, this is just demonstrating that when we call plot from a pd.series, we haven't done it from a data frame yet, it comes out as matplotlib.axes.subplots. So that's what we've seen before with this. So really, it's straight from a Pandas series. We might delete this cell because we don't need that anymore. But it's using Matplotlib. That's really handy to know. All right, now we've seen plotting straight from a series. Let's plot from our data frame. We got car sales. This is our data frame. We'll view it again. How about we make something similar to this, but using our car sales data? Yeah, maybe we get some dates and the sale price over time. We might add a little column to our data frame. Yeah, that sounds like a good project. But before this video gets too long, we're going to do that in the next one. So next video, I'll see you back. We're going to try replicate something like this, but using our data. So we'll get a mixture of manipulating data and plotting at the same time. That'll be good fun. In the last video, we created this bad boy here. Now, let's try and make something similar, but using our own data so we can practice a little bit of data manipulation along with plotting and put some of our Pandas and Matplotlib skills together. So what we'll do, we'll format the price column first. We'll get it into integer format because right now we don't want those dollar signs and columns and commas. We don't want those for when we're doing numerical operations. So to do that, we'll go car sales, and then we'll change the price column. We need to access the string. We saw this in the Pandas section. We go string.replace, and now we want to pass in a little bit of regex here. There we go. So essentially all this is saying is get the $sign, the comma, and the dot, which is here and here, and replace it. And we're going to replace it with an empty string. So we'll see what this does. Car sales. Oh, we need to add car sales there. So let's see what it looks like now. Okay, beautiful. But we've got 2 extra zeros on the end, so we don't want that. So we want to go remove last 2 zeros. We got car sales. We want to access the price column again. We're going to reassign it to car sales price. Again, it's still a string. So if we have a look at this, we go here, type, just to exemplify what we're doing with the dot string. Oh, it's a series. Okay, but that's all right. Well, it's still a string. So we're accessing it with the dot string method here. Maybe if we go 0, string. There we go. So that's accessing this little one here, and it's telling us that it's a string. So that's why we have to access it as a string first with .str. And now we want to remove the last 2 using slicing. Well, let's have a look at what car sales looks like here. Oh no, we've removed too many. So what we can do is rerun it. We're going to have to re-import our data frame to fix that little issue. That's going to just reset it. Because remember, Jupyter cells are running in sequential mode. So if we run this cell more than once, it's going to continually remove the last 2 digits of our price column as long as we keep running this. So we don't want that. So now our price column is in the format that we want. We're going to add a sale date column, which will be similar to the PD date range function that we used up here, pd.daterange. So let's do that. Data range 1, 1. We want to pass it a date 2020. Number of periods. So this is how many dates we want to add. We've got periods here. So that's a parameter. So that's going to add this one. We had 1,000 periods, but we don't want that many for our car sales data frame. We actually just want date period for each row here. So we can do that by going periods equals len car sales. And then we'll check our car sales data frame again. Beautiful. So now we've got a sale date here, which is sequential. That's okay. Maybe they all weren't sold on sequential dates, but we're just making an example of how we can start to manipulate our existing data frames. So the next thing, what we want to do is we want to make a total column. So we want to start to add up how much we've made from selling all our cars. So if we added 4,000 to 5,000 to 7,000, so this is where we can use something like CumSum, because it's going to add each of these prices cumulatively. So let's make a total column. This should be car sales, total sales. And then what do we want? We want the price column. That's right. Car sales price dot CumSum. Let's see what happens here. Car sales. Oh, what have we done? It's worked, but because our price column is still in string format, it's just concatenated the strings to each other. So let's have a look. Car sales price 0.dtype. Oh, that's a bit boring. Let's get it back to exemplifying that it's a string. There we go. So our price column is still a string. So to fix this, we have to change it first into an integer and then call the CumSum function. So we can do .asType int.CumSum. So what this is going to do is go reassign the total sales column to be the price column as an integer as type int dot cumulative sum. This should work in theory, but as always, run the code, then check. Beautiful. Okay, so this has gone total sales, 4,000 plus 5,000 is 9,000, plus 7,000 is 16,000, and then it keeps going right up to the end. So after we've sold all of our cars across these 10 days or so, we have 76,450. Beautiful. That's some good profit there. We can use that to fund our almond butter store. And now, let's plot the total sales. So we want car sales. We want to see what our total sales looks like over time. So kind of replicating this graph here, but with our own data. Car sales dot plot x equals sale date. And now this is where you can call .plot directly on a Pandas data frame. This is Pandas version of the Matplotlib API, or the wrapper, Pandas wrapper for the Matplotlib API. So we're just going dataframe.plot, and we're passing it our x, which is the date, and our y, which is the total sales column. So let's see what this looks like. Total sales. And we'll put a semicolon at the end so it doesn't print out. Beautiful. There we go. So this is just an example of how you can take some code right from the documentation or some example that you found online, and we've replicated it up here. But then we've taken the principles from it, or some of them, and put them together with our own data, and then created this little visualization here. So now we can visualize, okay, so say we sold our 10 cars over the first 10 days of January. Now our total sales is going up and to the right, which is very pleasing for our boss because that's the type of graph they want to see. Profits up and to the right. And so hopefully you're starting to get an idea of the kind of workflow that you can go about when you're working on your own projects or working on problems you don't necessarily know the answer to. It's all about searching up, trying to find some kind of example, taking information from that, and then seeing if it works with your own problem. Now, we've seen a line plot. How about we try a scatter plot? So we got car sales dot plot x. Let's do it with the odometer this time. Odometer column km. Beautiful. Is that the right column name? Yep. We've worked with this data frame before, so we're kind of familiar with what's happening. Price. And then when you're calling the plot function, there's a little parameter here called kind, which we can feed the type scatter to hopefully get a scatter plot here. Oh, what's happening? Scatter requires y column to be numeric. Is our price column not numeric? It's still not numeric because here we've called as type int. So this is only going to turn the price column into an integer for running this single line of code. It's not going to reassign the price column to be an integer. These are still strings in the car sales data frame. So what we can do to make this work, we want to reassign the price column to be an integer. Price equals car sales price as type int, because our prices are always going to be integers, right? Money is a numerical value, so it's okay to reassign this data type to be integer. This should work. So we got reassign price column to int, plot scatter plot with price column as numeric. So without this line of code, we'll comment that out. We're going to get an error here, value error, requires y column to be numeric, but what we're doing with this line here, if we uncomment it, to comment and uncomment code, we can do command slash. So I'm just pressing command slash here. We're going to reassign it as a numeric column. So we do this. Beautiful. Now we have a scatter plot of our odometer column versus price. And remember to remove this little piece of code here. You can put a semicolon right at the end. Excellent. Now, I'm kind of seeing a few examples here of how we can start to plot directly from a Pandas data frame. We'll see a few more, but we'll end this video before it gets too long. So in the meantime, before the next one, maybe you'll try plot a couple of these columns together, whatever kind of plot you want to do. You've seen a few, a bar graph, a scatter plot, a line plot. Have a practice of that, and I'll see you in the next video. Welcome back. So in the last video, we saw plotting a scatter plot or a figure directly from our car sales data frame. We also saw making a line plot and doing a little bit of data manipulation, like adding a date column and creating a total sales column using the CumSum function. But how about we look at a few different other kinds of plots from our data frames? How about a bar graph? Yeah, that's a good idea. Let's make some data actually, because we want to just keep practicing all these different types of ways of plotting, creating data, and just seeing as many different examples as we can. So we'll create X variable here. We'll go turn it into a data frame. So we want df equals pd.dataframe. X columns equals, we'll keep it nice and simple. We'll just go A, B, C, D. Wonderful. And now we'll have a look at our data frame. Nice and simple. So we've got some random values here between 0 and 1, it looks like, and 4 columns that are just simple A, B, C, D. Now to get a bar graph, we can do, well, there's one way we can do it, .plot.bar. This is our df here. This is our data frame, and this is just saying, hey, df.plot, make it a bar graph. Let's see what this turns out to be. Wonderful. So this has got a legend here with A, B, C, D, and then we've got the different values for each different row. So this is row 0. We can see A is 0.06, so it's fairly low here, but D is 0.95, so it's right up and high. That's an easy way to make a bar graph using a Pandas data frame and a few different columns. How about we do it a different way? Let's go, because again, there's always many different ways to do the same thing with these libraries that we've been looking at. So go df.plot. Remember how with our scatter graph, we had this kind parameter? Well, you can do the same with a bar graph. Kind equals bar. Put the semicolon at the end. We get the exact same plot. These are two different ways that you can plot a bar graph. You can also change the kind variable here. Which one should you use? It's personal preference, but to be honest, I kind of flip back and forth depending on what kind of graph I'm making. But I'm just showing you this so you've got an idea. If you see these two out in the wild somewhere, you know they're really just doing the same thing. What about next? Let's use our actual data, right? So that was a dummy plot. Let's use the car sales data frame and make a bar graph. We want car sales. Let's view it again. Always good to view your data frames. This is the kind of workflow you'll be going through when you're creating visualizations, is you'll be checking your data frame, making a visualization, checking your data frame, making a visualization, and just keep jumping back and forth. So never be afraid, especially when you're working through the start of a project, to just keep writing code, keep trying to understand your data. So we want car sales dot plot. Maybe we plot the odometer versus the make in a bar graph. We can see that maybe the make will be the X. So we'll have make along the bottom and then odometer as the Y. So let's see what that turns out to be. Equals X make. And then we want Y equals odometer. Ooh, typos. KM. Beautiful. Kind equals bar. There we go. We can see we've got our rows here across the bottom. We've got different makes. Toyota, that's how many kilometers are on the odometer. Honda, that's how many kilometers are on this example. What a bit of an extension might be is to group these together to figure out what the average odometer reading is for each different make. That would be something like consolidating cars of the same make and then averaging what their odometer is. So maybe that's a little bit of a practice that you could try to create an extra column over here or something like that. But let's move on to another type of plot that we've seen before. How about histograms? Histograms are great for visualizing distributions. So that's just the spread of data. So we got, of course, there's many different ways to do it. So we got car sales, odometer. We want to visualize the distribution of the odometer. Plot.hist, this is just exactly like we saw before with plot.bar, but now we're doing hist. Hist is short for histogram. So we'll have a look at this. Okay, so that's the spread of our data. This is that kind of that normal distribution curve around this sort of range, 25,000 to 100,000. And we've got a few here which are a little bit outside that normal curve here. So this might be considered an outlier because of how high it is. And if we come back to our table, our data frame, we can kind of see that this Nissan, which is this one here, has 200,000 kilometers on its odometer, versus the rest of these are barely scratching towards 100. So that kind of makes sense intuitively just looking at this. But you could imagine if we had maybe 1,000 more cars with all different ranges of kilometers, most of them would probably appear in this range if they were similar distribution to what we've got here. Now, what's another way of doing it? So if we go car sales, we'll make the same graph here. Odometer, KM, beautiful. We'll go plot. We're going to use the kind parameter here. Kind equals hist, and then we'll do it there. So same graph, just a little bit different here. We've used the kind parameter rather than just the .hist method. So one of the advantages of using the .hist, it has a little parameter here called bins. Now bins by default is 10. So this is, if you're wondering what a bin is, it's these columns here. What a histogram plot does is it takes the spread of data here and then buckets them into bins. So we got here 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is by default 10 bins. If your data doesn't fit into 10 different evenly sized bins, it might adjust the size here. But we can do that manually by passing a different value to hist to the bins parameter. So let's see that in action. Let's go .plot.hist. We're going to change bins. Let's do 20. We'll double it up. Okay, so we can see we've kind of missed that curve there. Now, what is the most ideal value for bins? It's kind of like an exploration. That's a lot of what data science and machine learning is. It's kind of just trying things out and seeing what works. So these don't really look that great. I think 10 is actually probably one of the best values. 10 is probably all right. Well, we do have only 10 samples. Now, what are you looking for here? You're looking for a big curve. Like, remember how we looked at the normal distribution? You want to try and find something like this with your histograms, a curve like this. If you can't find exact curve because your data doesn't fit this exact curve, that's not a problem. It's just about having a different go and figuring out what is the most ideal number of bins for your histograms. All right. So we've seen a histogram, we've seen bar graph, we've seen scatter plots, we've seen line plots on our car sales data set. Let's try do something a little bit similar but with another data set just to make sure that we've kind of got these methods down pat. So in the meantime, have a little bit of a practice, make a bar graph, make a histogram on the car sales data frame, and I'll see you back in the next video. We'll do something similar with another data set. Welcome back. And so we've done a whole bunch of plotting so far, and don't worry if you're sort of a little bit confused at the moment, like you're like, Daniel's showing me all these plots, I'm looking at different data sets. Whew, how am I going to remember all this? It's all right. That's perfectly fine to feel like that. It's going to take a little bit of practice to start to understand different kinds of plots, what you should use which plot for, but that's all part of the process, right? It's just having a little practice, having a go and just trying it out, seeing what it looks like. Does this make sense? So that's why in this video, we're going to do a similar plot to what we've just saw before on the car sales data set on another data set. Let's try on another data set. And if we come up here, we've got heartdisease.csv, which we've seen before, which is a data set which has different parameters of patients and whether or not they have heart disease. So let's import that as pd.readcsv, as we're going to call it just heart disease. And so we'll go heartdisease.csv. Beautiful. Now we'll have a look at it just to make sure we know what's happening. We'll only view the first 5 rows because there's about 300 in this one. Excellent. We have these parameters. We've seen them before. And we've got a target column right on the end. So what we might do is create a histogram just to see the distribution of the age column. So heart disease, age, .plot.hist, and we might just see the default number of bins. Can you remember how many that will be? Shift tab, bins is going to be 10. Beautiful, so we'll just leave it at that. Okay. So this is where we're starting to see that curve, right? This is that normal distribution. It's very common. So we're kind of getting that curve here. We would say that most of the patients are around, it's this line here, so maybe late 50s, early 60s, thereabouts. So what if we change the number of bins? So let's go bins equals 20. Okay, we're starting to lose that curve shape a little bit. 30. Still relatively there. We're definitely starting to see this more pronounced line here, right at the late 50s there. Maybe we jack it up to 50 and see what happens. All right. So that shape is still relatively there. Our initial shape, that what we got from just having 10 bins, is kind of consistent the whole way through. And maybe we'd look at this and go, okay, this one's a bit of an outlier. These are a bit of an outlier. Why are they outliers? Well, because they're so far from the middle. When you hear the word outlier, that's kind of what it's talking about. In statistic terms, it's about more than 3 standard deviations away from the mean. Now, of course, that definition will change depending on what data you're working with, but this is kind of a way that you can visualize it. So let's take that back to 10. That looks pretty good. All right. Now, these kind of visualizations are the things you'll do whenever you deal with a new data set. Let's finish. There's one more type of plot we haven't looked at directly from a data frame. And that's subplots. So we'll finish that off. We'll go heart disease dot head. Okay, this is our data frame. Now let's plot every single column's histogram in one plot. Let's see how we would do that. Heart disease. So we've got the age histogram here, but let's just make one for all of these and check the distribution. .plot.hist. So remember, this is just going straight from the entire data frame. Up here, we selected the age column. .hist. And maybe we want subplots equals true. Does that make sense? Because we want to put it all on the one plot. Keyword args, so that's part of that. Maybe if we could read down a little bit. Examples. So this is one of those scenarios where if you wanted to use this .hist method and have it all on one plot, because the docstring doesn't really have an example of putting it all with the subplots, this would take a little bit of research. So you might look up a question like how to plot a histogram on subplots from a Pandas data frame, and then you'd find this little parameter here. Only reason I know it is because I've had a little bit of experience plotting subplots from Pandas data frames. So let's see what this looks like. Might take a little while because we're plotting 10 columns or 15 columns thereabouts. Oh, that doesn't look very good, does it? We've got overlapping plots, we've got legends everywhere, we've got, these things aren't even to scale, so maybe to fix it up, we'll change the fig size. So what do we want? We want width, height. We want it to be a bit higher so it stretches it out because there's hardly any space here. Okay, that's looking a little bit better, but still you got columns like this which are just all clumped up here because what it's doing is it's using the same scale for all of them. But in reality, these all have different measures. That's not very ideal, right? It might work out for some, like this one, cholesterol, might work out for that column, but it doesn't work at all for the other ones, right? So slope, old peak, exang. So what can we do? Well, this code runs, but it's not ideal. And then there's different scales, and it's probably a bit too much going on for this plot to even be meaningful. But this is a good segue though. Now we've covered a few simple plots directly on a Pandas data frame. Let's have a look at how we'd make some visualizations using the OO method. So remember back in a previous video, we talked about OO method, which is subplots. Don't worry if it's confusing, we'll have a look in a second. But what we've been using so far is plotting directly from Pandas using the stateless method. So in the meantime, have a practice, keep using the plot, make another plot of your own before we come into the next video, and I'll see you there. We'll practice using the more flexible object-orientated Matplotlib API directly with Pandas. Welcome back. So in the last video we left off saying that this plot probably isn't ideal. We've got a few subplots going on here, and we've been using the pyplot method, plotting directly from a Pandas data frame rather than the object-orientated method. And I'm sure you're wondering, you're going, Daniel, you've introduced so many different ways of plotting, and you're telling us there's two ways of doing it, and you're saying one is less ideal than the other. Which one should I use? And that's a perfectly great question. So which one should you use? Pyplot versus Matplotlib OO method. Now, there is no real definitive answer here. The documentation on Matplotlib will push you towards the OO method always. However, when plotting something quickly, okay to use the pyplot method, right? So what we've seen up here, when you want to get a quick visualization, maybe not something like this, but definitely something like this, it's okay to use the pyplot method that we've gone through in the last couple of videos. But when plotting something more advanced, use the OO method. So we're going to see an example of that in this video. Something a little bit more advanced than just something singular like this. But if you're just making a quick plot like this, you just want to see the distribution of a column, it's perfectly okay to go dot plot. Well, now we'll see the OO method in action. Let's create a subset of our data frame so we can do a little bit of data analysis. Let's say we wanted to explore the patients which are over the age of 50. We only wanted to look at those patients. And we want to create a little bit of a plot and start to do some data analysis on those. So we'll create another data frame called over 50, which is equal to our heart disease data frame, which we'll get a little refresher here so we know what it looks like. This is the kind of workflow you'll be going through, is looking at your data frame and going, okay, my colleague or my teammates and my boss want to know what's some data analysis of our patients which are over 50. So let's do that. We can access those by using Boolean indexing. So we want heart disease, actually we want to use the age column, which are greater than 50. Wonderful. And then we want to have a look at our over 50 data set. What have we got wrong here? Age, key error. Oh, I've used a capital A. That's all right. Wonderful. And we might check the length of this. 208. So we have 208 versus about 300 or so of the original data set. So that's fine. Dot head. Wonderful. And again, we've dropped out these two rows, so 37, 41, using our Boolean indexing. So now it goes 0, 3, 4, 5, 6, but the rest of the columns are still the same. How about we start with a scatter plot of the age and cholesterol, but we want to color it with the flavor of the target column. Whoa, that's a lot going on there. Let's see the code first, and then we'll figure it out from there. Over 50.plot kind equals scatter. And then we want x equals age. And then we want y equals, we want the cholesterol column, which is this one here. CHOL is short for cholesterol. And then we want to color it using the C. So C is short for color via the target column. So we want plot kind scatter. Yes, that makes sense. X, age, Y, chol, cholesterol. Kind of a hard word to say, CHOL. And the color is target. Let's see what happens. All right. So we can kind of see what's going on here. We've got chol on the Y. That makes sense. The X doesn't really show us much. And C is giving us this color bar to show us that, because target has values of 0 or 1 for if someone does have heart disease or they don't. Does this look okay to you? To me, it doesn't look very good. It's doing what we want it to do. It's got different dots on here if they're a target value of 0 or 1, but it doesn't show us anything on the x-axis, and these colors aren't really that great. So let's spruce things up a little. And how can we do that? With the OO method. So this is the pyplot method, aka plotting directly from a Pandas data frame with plot. Now let's do OO method. We're going to recreate this, but using the OO method. So let's go fig, ax, we've seen this before, plt.subplots, and we might go fig size just to have some practice adjusting the size of our figures. And we'll go 10, 6. We want a width of 10 and a height of 6. These are in inches, by the way, I believe. So over 50.plot. Now this is going to look very similar to what we've done up here, but there's one slight difference. Kind equals scatter. Wonderful. Now we could copy and paste, but we're not going to do that because we're in the habit of writing out code. Y equals chol or col. C, we use the target column as color. And then the last part is the ax parameter. So when we're using the OO method with pandas, the plot function gets this ax parameter to tell us, hey, we're using the OO method and we want you to plot this data on this axis, the one we've just created. So let's see that in action. Ax, we'll put a little semicolon at the end. Beautiful. So what we've done is we've recreated the same plot, but it's already looking a little bit better. It's bigger because we've put the fig size parameter in there. And now because we've passed the ax method, we've now got this age column which has been labeled. Beautiful. Actually, we might give this one a chance and say, hey, let's up this fig size and see if it does the same thing. Equals 10, 6. We still don't have the age X label there. Well, the OO method is already pulling out ahead. Now, what we might do is we set the X limit to be a bit wider so we can have more space on our data frame. So let's have a look what that looks like. If we're using the OO method, we can access the axis here. And remember, the axis is just this space that we're plotting data on. If we go back to the figure of our anatomy of a Matplotlib figure or plot, axis is this part here where we're adding data, whereas figure is the entire thing. So let's go back. We want ax dot set xlim to be 45, 100. Can we figure out what this does before we even look at it? So set xlim. We could do shift tab, but I want you to just have a think about it. So ax set xlim 45, 100. So that's all right if you didn't get it. If you press shift tab and read it, you cheated a little. That's also fine. That's actually a good thing to do, is start exploring what shift tab does. But this is going to change the limitations of our x-axis to be from 45 to 100 instead of what it is now, which is about 50 to 80. So let's see what happens. So see how we've got like a lot more white space over here now because we've upped the x limit. But if we didn't want to do that, we could comment that out and that looks a bit better. Just giving an example of how you could quickly adjust the limitations of your axes if they don't look too good. But Matplotlib is generally pretty good at creating axis limits that are suited to whatever data that you're using. Now this plot is okay, but it definitely could look nicer. So this black and white is kind of hard to get. This color bar is not really offering much at all. So let's take a little break there, and in the next video we'll make this plot look a little bit nicer and we'll build off what we've already done here. Welcome back. So in the last video we saw two different ways of plotting from a Pandas data frame. One with the pyplot method, and we created this plot here. And then the other with the object-orientated method. I'll be honest with you, this is not directly the OO method. We've kind of passed it off here. But we're still kind of using the pyplot method here, but we've tricked it a little in combining it with the OO method. So what we're going to do is recreate this, but using the object-orientated method from scratch, and then we're going to customize it to make it look a bit more prettier. Let's start. We'll create a new figure and a new axis. We'll put in here OO method from scratch. And up here, we might go OO method mixed with pyplot method. So then we'll go plot.subplots, and we know our fig size. This is a pretty good size, so we're gonna reuse that. 10, 6. That was correct. Yep. And then we want to do plot the data because that's part of our Matplotlib workflow. We'll call our figure. We'll rename it to scatter. we'll go scatter equals ax.scatter because we want a scatter plot. And we're going to go x, which is our age column. So we want over 50, because remember we're working with our over 50 data frame now. Age, and then our y column is going to be over 50, and we're going to have chol or col for cholesterol. And then we want to color it with over 50, which is the C here. We want to color it with the target column. And what I mean by color it is just literally change the color of a dot depending on what the target column value is. And now let's see what this looks like. Okay, groovy. We're starting to get a few different colors here. It's looking similar, but it's still missing a few things. Like we don't know what the x-axis is and we don't know what the y-axis is, but that's okay. We've got a very flexible method here because we're using the object-orientated method from scratch. So now what we're going to do is customize, and we're going to go ax.set. We want to add in a title. Beautiful. So we got heart disease and cholesterol levels. That's all right. Keep it nice and concise. Then we want x label equals age. And we'll add a y label, which is cholesterol. Now you could put the units here. I'm not actually sure what the units are of cholesterol. That would be something we'd have to look up. So we'll just keep that as just cholesterol. Nice and simple for the time being. And let's see what this looks like. Starting to get better. All right. So we've got a title now. We know what the y-axis is and we know what the x-axis is, but we're not sure what these dots are. Right, these are just purple and yellow dots. Or what color is that to you? That's a purplish to me. So maybe we, oops. See, that's what happens when you run it without the semicolon. You get this code output. So maybe we add a legend. So how can we do that? We go ax, we call the legend method, legend. And then we're going to use this little star, which is kind of like just unpack all the values of title equals target. Let's add a legend to our axes, which is this here. And this little star is saying, hey, grab the values from scatter and unpack the legend elements, which is going to query this C parameter here and look back up at this data frame and go, what values are in this, in the target column? So we got ones and zeros. And then it's going to create the legend built off those elements. So let's see it in action. Path collection has no attribute legend elements. Oh, there we go. Typo. Beautiful. So if you type it right, that's what it's going to do. It just goes into the scatter variable, which is what we've created up here. And then it's going to find the legend elements, which it gets from this C parameter, which it then looks back up into our, we'll put it here so we can see, over 50 target dot values. It's going to look at this target column and then find that there's ones and zeros. And then it's going to color the legend the same as the values on here. So now this is looking a bit better. The object-orientated method from scratch is looking far better than what we've built here. This is how we've done a few more lines of code here, but now you're starting to see how customizable this object-orientated API is. What if we wanted to add a few more things? Well, the beautiful thing is we can do that. What if we wanted something like a horizontal line across here to indicate the average cholesterol? Let's look up the documentation, how to add a horizontal line in Matplotlib plot. Matplotlib.axis.axHline. Okay. What will this do? Add a horizontal line across the axis. Well, I guess that's what we want to do. So let's try it out. We want to go maybe back up in here. Add a horizontal line. So this is the kind of workflow you'll go through. Like if you wanted to do something, that's perfectly fine. You look it up, you go to the documentation, and now we're going to try this out. Axes.axHline. Let's see what happens. Ax, because this is our axes. dot ax h line. Wonderful. And now we want to give it the value. So we want over 50. So if we go Shift Tab and see what it takes, Y. So we need a Y axis. So we want to give it the same Y here. So we want the cholesterol column. Yeah, beautiful. And now we want the line to be the mean of that column. Beautiful. Now we've got a straight line, but maybe we wanted a dashed line because that looks a bit better. We've got line style. So this is another one of those keyword arguments. So this one here, keyword args. That's not really going to appear in the doc string. Maybe if we scrolled right down, there we go, line style. So you could also just look up how to style a Matplotlib line style reference. You come across something like this, but in our case, to save a little time, I've used this dash line before, and that usually looks pretty good. So there we go. We've added a horizontal line. Now, that's starting to look much, much better than what we had before. Don't you agree? Well, I certainly do, but I'm kind of biased because I created this plot. Now, this is just another example, right, of using a different data set, of creating your own custom plot, and then working with different kinds of data. So we've got cholesterol, and then really starting to use the Matplotlib API to create whatever kind of plot you want. Now, you could imagine you could create a subplot of this. We might actually do that in the next video, is create this, but we'll work it in with a subplot. So we might add another variable from the data frame and put it into a subplot of this. So let's see that in action. But in the meantime, have a little bit of a play around. Maybe you can take a step ahead and see if you can create a subplot of heart disease and cholesterol levels with maybe heart disease and what's another column that you could use? And this one, Thel-Ach, which is max heart rate. See what you can do creating a subplot with cholesterol and max heart rate. If you want me to go along with you, we'll do that in the next video. Welcome back. So now we're really going to step it up a notch. We're going to see the full power of the Matplotlib object-orientated method. We're going to build upon what we've done here. So we've created this heart disease and cholesterol levels with our over 50s data frame, but now we're going to add a subplot to this. So we can visualize cholesterol levels, and we might get our over 50 data frame here so we can stop having to scroll up. We're going to combine that with Thel-Ach, which is, I'm not sure if I'm pronouncing that by the way either, Thel-Ach, which is max heart rate. So we want to have a subplot where we've got cholesterol and Thel-Ach on the y-axis, but they're both going to have age as the x-axis. So let's see that in action. We'll title this subplot of col age Thel-Ach. Beautiful. Oh, we want to go here. We're going to recreate this. We could copy and paste this code, but again, we want to practice writing from scratch. So let's see it in full force. Fig. We want to use the object-orientated method. Now, if you've had a go at creating a subplot on your own, this is the way you might have used, but if not, this is how I would create a subplot of these two. So remember, we want two different axes. So fig, ax 0, and ax, this is going to be ax 1. There we go. So what this is saying is now we're creating a single figure, but it's going to have two axes on it. Remember, axes are this here, y and x, where you can add data. So let's use the same command as before, subplots, and we want n rows equals 2. We want n cols is going to be 1. Our previous figure size was 10 and 6, but let's make this 10 and 10. See what that looks like. And now we want to go add data to ax 0. Actually, let's see what this looks like before we even plot. Fig size, oh, forgot an equal there. Beautiful. So now we've got two blank canvases to start adding our data on here. So we want to add data to axis 0, which is this one here. So just going to be this exact same as before. We'll do something like this. So now we're going to add some data to axis 0. Just like we've done up here, we're going to do something similar to this. But again, we're not copy and pasting. We'll do it from scratch. So we want scatter equals ax 0 dot scatter, and we're going to go x is going to be the over 50 age column, y equals over 50 And this is going to be just a cholesterol column. Beautiful. And then we're going to go C equals, we're going to color it with the over 50 target column. Now let's see what that looks like. Beautiful, we've seen this before. So customize ax0, and we want to go ax0 dot set, and we want to add a title. This is going to be heart disease and cholesterol levels. Wonderful. And then we want an X label, which is going to be age. And then we want to go Y label, which will be cholesterol. Nothing new here. We've seen this before, but now it's only on axis 0, which is amazing. Maybe we add a legend to ax0, same code as before, ax0.legend scatter.legend elements. And then we're going to go title equals target. Beautiful. What did we have up here? We had a mean line, so that's what we can do with the H line. So add a mean line. So we're just replicating the plot we've done before. ax.0.ax H line. Then we need to pass H line to Y. So we want over 50. It's going to be the cholesterol. So we'll do cholesterol.mean, and then we'll add a line style as dash dash. And that should be the same plot as what we've got above. But now it's on a subplot. So I want to challenge you to, before we go through it, see if you can replicate what we've done here, but with the thel-ach column instead of the cholesterol column on this subplot here. I'll give you a second. All right, if you've had a go, all good. If not, let's go through it. So now we want to add data to ax1, because remember, we've got ax1 up here. Excellent. Same thing we've done as before, but this time all we're going to do is change it from ax0 to ax1, and then of course the column will be different. Or the data that we use will be a little bit different. So in this case, it's one x. The x is still going to be the age column. What's going to change is what's on the y-axis. So we have over 50. thel-ach, wonderful. Color is going to be the same because we're focused on our target variable, which is whether or not the patient has heart disease. So there we go. Let's see what this looks like. Okay, so we're starting to get somewhere now. We've got some data on both our axes. Let's customize it just like we've done with axis 0. We're going to do that with ax1. ax1.set. Let's add a title. Title, this one will be heart disease and max heart rate. Wonderful. And then we're going to go X label. Can you remember what that is? Just the age, because we're using the same column for the X. Now the Y label. This is going to be thel-ach. So we'll actually put in max heart rate because we want it to be a bit more communicative than just thel-ach. So if someone came and had a look at our plot and didn't know what thel-ach meant, they'll know it means max heart rate. Okay. Starting to make some progress. Now we still have a couple more things to do. We want a similar setup to what we've got here. So let's add a legend to ax1, ax1.legend. Now again, we're creating quite similar plots here with the subplot that we're making. So these two are quite similar. As you've seen before, you could have a scatter plot here and you could have a histogram here or something like that. But we're just using this as an example. So title equals target. Wonderful. We'll add a mean line as well. So ax1.ax H line. Now we're going to color it with the Y is going to be this time, instead of cholesterol, it's going to be thel-ach. Wonderful. .mean. And then the line style, we're going to keep it with our trusty dash. And then we'll add a semicolon here. And let's have a look. What have we messed up? We got an error. Line 2D has no property line style. This is classic. Typos everywhere. There we go. So it's okay to make errors, right? You're never going to type out all the code correctly every time, the first time. Beautiful. This is starting to look really good. Okay. what we're starting to see, we've got an age x-axis label here, but this is also age. So maybe we could tell them to share the x. So let's see, where could we add that? Maybe up in here. I want to share the x. So share x equals true. But now we can remove this label on axis 0. So what is this going to do? If we put in share x equals true, what do you think? There we go. So what this has done is it's telling our plot to go that our subplots here have the same x value. So we don't need to put in the age label there. Maybe you would keep it in there for a bit more, so it's a bit more communicative. That's kind of one way you can start to clean up your plots. And now what we might do is add a title to this overall thing. So we've got both subplots are titled, but we might want to title the entire figure. So let's see how we do that. Add a title to the figure. Now this is fig, because remember, we've created a figure and we've added data and customization to the axes. But now we want to start to access the figure directly, which is that big blue square on our Matplotlib anatomy. We filled up these two on our subplots. Now we want to title our figure. So we can do that with fig.sup, which stands for, I think it stands for super title. I actually don't know what sup stands for. I just know that it's subtitle. And then we go heart disease analysis. And we'll create the font size. We want it to be pretty big font size and a font weight of bold. We'll put a semicolon at the end. Beautiful. Look at this. Maybe we have to zoom out a tiny bit so we can see it all in one hit. There we go. Now you're starting to see what this is kind of looking like. Remember right at the start in the concept lecture, we looked at the anatomy of a Matplotlib figure. We looked at that plot and it was quite complex. There's a lot going on. Well, what you've done is you've just followed along and recreated something very similar. Now what we're going to do in the next video is style this a little bit better. So fix up some of the colors. The important thing to remember is it looks like a lot of code here. It actually is. We've got 25, 30 lines of code there. But what we've done is we've built this figure from scratch using the object-oriented Matplotlib method. And so now what seemed at the start to be a very complex and complicated plot is actually just quite simple, right? You create a figure, you create a couple of axes, you add data to the axes, you add some customizations like titles and a legend and a horizontal line, and you start to get something looking like this. Now that's something that you could put in a demonstration or show your colleagues in a presentation, something like that, right? Now you're starting to see just how powerful Matplotlib, the object-oriented API, can be. All right, let's wrap this video up. Have a practice, maybe create your own subplot without a scatter. Try a histogram and maybe a bar graph. Can you do that on the same figure? Otherwise, I'll see you in the next video and we'll learn a little bit more customization of these plots. Alrighty, so we've seen how to create quite a complex plot, but in terms of customization, we've kind of glazed over these set parameters and title and X label and Y label and not. So what we're going to do now is look at customization of plots a little bit more in depth, and by the end of this video, perhaps the next video, we're going to replicate or transform this plot into something which looks exactly like the one we've got here. So the data is still the same, but you can kind of see that there's a different style in terms of color, line, and just the text is a little bit different. The font, the axes are a little bit different. So let's get into it, eh? So what we're going to do first is have a look at some different styles of Matplotlib. So the beautiful thing about Matplotlib is that, again, one of its other customizable parameters is the style of plot that you're using. So if the default one, which is what we're kind of using now, doesn't quite look how you want it to look, you can try other different styles. So let's go down here. We'll make a little section, customizing Matplotlib plots and getting stylish. Yeah, that's what we're going to do. We're getting stylish. See the different styles. available. Now what this is going to do is if we call plt.style.available, it's going to tell us what kind of styles Matplotlib has available to us. Right now, by default, by just importing Matplotlib right at the top, we're using the default style. But as you can see, there's about 20 other styles that you can use. So let's try out a few of these, but first we'll remind ourselves of what the default style looks like. That way we can compare and see which one we like best, because I've tried a few of these and I kind of know which ones I like, but again, it'll come down to personal preference of what kind of style you want to use. So this is the default style. We're plotting the car sales data frame that we've seen a few times now. So car sales.head. This is our car sales data frame. We plot the price column. We've got a beautiful line graph there. Now that's pretty good on its own. So let's have a look. Maybe we want to use plt.style.use, and I'm going to choose the Seaborn white grid. Let's see what that looks like. We'll type that in, Seaborn white grid. Wonderful. So that's going to update Matplotlib's style internally. So if we call the same plot that we did before, price.plot, put a semicolon at the end. See how it looks a bit different? Now we've got some grid lines here. We've got a little bit of a gap here. Maybe the axes limit is a bit higher for the y-axis. But generally, quite the same as the default Matplotlib style. Now, again, you might think that the Matplotlib default style is perfect for your needs, and that's okay. We're going through these different styles, right? Because I want you to understand just how customizable these plots are. Let's try another. Plot.style.use, and this time we might just use the default Seaborn. So if we go up here, Seaborn on its own. Now Seaborn is another plotting library that's built off Matplotlib. And now we're going to go car sales dot price plot. Wonderful. So now kind of a little bit different. So this is white grid, so we've got a white background. That kind of makes sense. But the default Seaborn style kind of has this grey background. But again, we're still plotting the exact same data, just mixing up the style, mixing up the colours. Why don't we try another kind of plot? We'll do car sales.plot. Now that the style is set to Seaborn, how about we check the odometer? KM, and then let's go odometer versus price. We've seen this plot somewhere before. Kind equals, we'll make it a scatter plot. There we go. It's a little bit different to the original scatter plot that we've seen before. This one maybe look a bit better to you. I personally prefer the Seaborn style. So I might run this line of code when I start a new notebook. So run it right at the top under my Matplotlib imports, just to make sure all my plots are in the Seaborn style. So we'll save that there. That's another good habit to get into, is just hitting Command or Control S every so often with your notebooks. And we might use one more plot just for good luck, plot.style. This time we're going to use ggplot, which is up here. ggplot is a different kind of style. And so we'll do the price graph again. Price.plot. There we go. So now we've got a bit of a different, maybe a creamy grey. I don't know how you would describe that color, but the line is definitely changed to red. As you can see, Seaborn kind of comes with some axis titles by default, whereas these don't have them. Okay, now these are some sweet looking plots. And now we've seen how to change up the style. How about the titles, the legend, the axes? Like this one doesn't have any. It just has numbers on both axes. If a plot is worth 1,000 words, adding a few more can't hurt, right? So let's do that. We'll create some dummy data. Create some data. X equals, we've seen this before, numpy.randn. And we'll go 10, 4. There we go. We've got an array there. Wonderful. Now we'll put that into a data frame. We've created a data frame like this before, but we're just going to practice reworking some of the things we've already done. That way they start to sink into memory a bit more. CD. Wonderful. Now this should give us a data frame. Yep. 4 columns, 10 rows of some random numbers. Beautiful. And now we're going to create a simple plot. Now this, we're going to use a PyPlot API because we want to just create a plot quickly. If you wanted to create something more in depth like we've done here, where is it? There. You would probably use the Object-Orientated API. But because we're doing some quick and dirty plots at the moment, we'll just use we'll plot straight from the Pandas Data Frame with the PyPlot API. So kind equals bar, and then we're going to look at the type of ax. Beautiful. So this is a bar graph that we've built just off this data frame here. We've got some negative and positive values, different colors for the different columns. That all makes sense. And now we're going to customize our plot with the set method. So we got ax. We'll rewrite it. Ax, so we can see it all in one cell. df.plot kind equals bar. Wonderful. And now we want to add some labels and a title. So we want ax.set, and we got title. So as you could probably guess, this is going to set the title. Random bar graph from data frame. Wonderful. I've spelt graph terribly. That's all right. There we go. And then within this set has a few parameters here. So if we go shift tab, there we go, shift.keyword args. So this is probably another one you probably want to look into the documentation to start to figure out all the different kinds of customizations you can add to it. But we're just going to go through the main ones, which are title, X label, and Y label. They're probably the bare minimum you'd want on any plot or figure that you create, right? You want to know what's on the X-axis and you want to know what's on the Y-axis, rather than just it having numbers there. Row number, random number. Simple titles. And then we'll make the legend visible. Now this one is kind of confusing because the legend already is visible. But if it wasn't visible, some plots do have a legend already built in. So you can use this ax.legend.setVisible and then set visible to true, which won't really change ours because it's already visible. But let's see what happens. What do we got here? Axis plot has no property title. Oh, another typo. There we go. Wonderful. So now we've got the exact same plot as up here, but now we've just used the set method to add in an axis label on the Y and the X and a title. So that's starting to look a lot more communicative right there. All right. Now, what if the style we're using doesn't quite suit the plot we're trying to make? So that's what we'll probably look into the next video. We'll change around the style within a set style. So if that sounds a little confusing, don't worry, we'll go through it in the next video. But in the meantime, try out creating some of your own plots using plot.style.use and pick anyone from this list and just start to get a feel for what the different styles look like. My personal favorite is probably Seaborn or Seaborn White Grid. Seaborn generally just has some great styles down here. All right, let's take a little break, write some custom code, and I'll see you shortly. Alrighty, now we've seen a few different ways of changing the style of our plots and figures. What we might do is change the style again, but from within an existing style. Let's see what that means, because that's kind of confusing when you hear it for the first time. What we might do is come back up here and take this code. Now this is one of the only times we're allowed to copy and paste because I think we've kind of seen enough for now of writing out this type of Matplotlib style plotting. So we'll come right down because what we're focused on now is just checking out how to change the style from within a style. So if we go here, now what we want to do is we want to, at the top of this cell, we've probably already set it above, but I'm going to reset the style. So plot.style.use, and I want Seaborn White Grid. That's the style we're going to stick with for the time being. Set the style. Wonderful. Now we've created our over 50 data frame up before. That's the heart disease patients that are over 50. And this is going to plot out a scatter graph with this data. It's already got some customization, a legend, and a horizontal line. So let's see what this looks like with the white grid style. Just for a quick refresh, we'll go back up. This is what it looks like. This is the original one. We've just copied the code from this cell. And so we're going to come down, take a quick snapshot of that in your mind, and we're going to see what the Seaborn version looks like. So let's hit Shift Enter. Okay, so a little bit different. We've got the white grid. That makes sense because we're using Seaborn white grid. But these colors, I think the line's a different color. It's red now. And these dots are black and white by default. What happens if you say, I like the Seaborn white grid style, but I don't really like these colors that it's putting out? Well, as you might have guessed, the beautiful thing is Matplotlib, it's got a whole bunch of different colors and we can change up the colors. So if we go in here, there's a little parameter called CMap, which stands for color map. And there's a whole bunch of different styles. I've kind of explored them myself. I personally like winter or summer. You're thinking, Daniel, this is seasons. All it's going to mean is that this changes the color scheme. And let's see what happens. Beautiful. So now our black and white dots are of a wintry color scheme. You can tell the difference a lot more than just pure black and white. Now, if we have a look, if we go to, I believe it's Matplotlib Colors tutorial. Now, this should show the Matplotlib documentation, where you can see a whole bunch of different colors. If we go here, Control F, so colors, that's what we're after. Choosing color maps in Matplotlib. So again, there's a lot of information here. If we go down, so it's got some different patterns here. If we keep going down, you'll start to see, if you type in this as a string, plasma, let's see what happens here. That's going to change the color map. So let's go back to our notebook. We might type in plasma. Okay, so it's changed it back. I personally prefer winter. You can also do summer. Let's see what that looks like. Okay, that's all right, but still I think winter's my favorite. I've had a practice with these C maps. There we go. That looks great. But this is in the Matplotlib documentation. So tutorials /colors/color maps. And you can keep scrolling down. There's a whole bunch here. If you just wanted green and blue, or if you just wanted blue and purple, you can use these little color codes, PU, BU for blue and purple, or yellow, green, blue. We'll keep going. There's actually quite a few, right? So it's all about experimenting and trying to figure out which colors you personally prefer, or which colors best demonstrate what you're trying to show in your Matplotlib plot. But this line over here, that's not really offering much. So let's check out how we can kind of constrain our plot to certain widths and certain heights on the different axis values using xlim and ylim. Let's grab our double-sided plot from before, our subplot. We'll grab that code. Again, this is one of the only times you're allowed to copy and paste code because there's quite a lot of it. So to save time writing it out, we'll bring down the graph because what we're focused on is customizing the Y and X axis limitations. We'll put that down there. So now we've just copied and pasted the code. Take a snapshot of this one as well. From up here down to here. Now if we run this, it's going to output that subplot that we saw before, but with the default Seaborn colors. So what do we have to do? We have to change the CMap. So let's see it in action. CMap. Again, this is just in our scatter plot like we've done up here. We've added a CMap parameter. So we'll do that here. CMap equals winter. Let's see what happens. Beautiful. That changes axis 0, so the first plot. Now we have to do the same for axis 1. We'll add in CMap equals winter. Beautiful. We'll go down and have a look. Beautiful. So now we've got two really good looking plots right here. So if we go back to our anatomy of a Matplotlib plot, starting to get really close to what we've got here. But as you can see with ours, we've got this line here, and this one up here. Whereas on here, it's kind of clean. The edge is nice and cut off at 50 there, at 200 up there. So let's see how we would do that. What we're going to do is come back up to our code. And now, in the set parameter, we could do it in there, but I'll show you another way of doing it. So we'll customize axis 0 first, just to show you what's going on. Axis 0 dot set ylim to be, what do we want? Yeah, so we want to cut it off at about 50. Let's try that. So set xlim. So we're going to do that 50. Remember, we can always change this. So this is going to be change the x-axis limits. There we go. So let's see what this does. If we go Shift Enter. Beautiful. So now we've cut off that line that was here before. So let's do this just to see what happens. Run. So that's what we've done. We've removed this line because we've changed the x limit of axis 0 to be 50. Remember, both of these are using the same x-axis as age. So let's do it. Let's keep that in there. We'll change that limitation there. We're going to add the same thing to axis 1. We'll put it under here. Change x1 x-axis limits. Oh, we're going to go x1 dot set xlim, and we're going to change that to be, I think it's the same, 50 and 80. Nice and simple. 50, 80. And we're also going to change the y limit on here to remove this top line to be a flat 200. Maybe we go from 50 to 200 or 60. 60 to 200, I think that'll be a good range. So we'll do that as well. x1.set ylim 60, 200. Now let's see what happens. So now take a quick look at what we've got here. We've got this graph, we've got this line here, we've got this one, we've got this line here, and we've got this top line here. So let's see, because we've changed the xlim and the ylim of axis 1 and the xlim of axis 0, hopefully, if we've done it all right, beautiful. That's what we're talking about. So now we've fully replicated the plot that we have here. We've got the exact same thing going on here. We've cleaned up the x-axis, we've changed the color, we've changed the style, and you can't really see it all in one hit. So let's zoom out a little bit. There we go. So that plot is looking pretty darn good. I don't know if you agree or not. Maybe you create your own style, maybe some different colors or something like that. But to me, that looks like something we can share. So that's what we're going to look at in the next video, is saving and sharing this plot. So have a practice around, maybe change the limitations with some different data, or change the style, change the CMAP, and see if you can create your own version of this heart disease analysis. Whoa, you've come a long way. Check out this. We've created, in the past few videos, we've worked towards creating our own customized plot. Now, of course, the final step in a Matplotlib workflow is to share this with someone else. Now, of course, if you've been working through your Jupyter notebook, you may put some communication up here, like you might create a cell, and it's like, this plot shows some information about the heart disease data set. Something like that. Of course, you might go a little bit more in depth than that to communicate your work, and then you could share your notebook. But what if you didn't want to share a notebook, you're doing like a presentation where you can't really just run through all the code and show someone what you've done? So what you may need to do is just export your figure. Now, probably the easiest way to do this, and it's the way I've done it in the past, is just to save the image as. You right-click on it. You could save it to downloads, or I could save it in my machine learning course, sample project. I'm going to save it there. I'm going to go heart disease analysis plot. And let's see what happens. It's going to be a format as a PNG image. We'll click save. So that's going to download it. But then if we go back to here, we can see here, we've got heart disease analysis plot. Beautiful. So that's something that you could put into a keynote presentation. It's exactly what I've done to do this, but I've just added some of my own custom drawings on the side here. So if you had to go into, say, a meeting or, say, a project presentation, you needed to show what you'd been working on in a visual format, because that's often how most people will understand things pretty quickly. You can take something like this with you. Another way to do it via code is with the save fig method. So again, when we first created this up here, we've created a fig, aka a figure. So this figure is going to be stored in Python memory at the moment. And so what you can do is call fig.savefig on this, and then we can go heart disease analysis plot saved with code.png. So this is going to save it with code. So potentially in the future, if you were creating a lot of these style plots, you may put this code here, instead of retyping it out all the time, you may put something like this into a Python function, and that way you could put this line of code at the end of it to export your figure after the code is run, after the function's been called. So let's see what happens if we call this fig.savefig. It's not really going to output anything, but if we go back to here, we've got heart disease analysis plot saved with code.png. Beautiful. And that is the default style. So if you export it with savefig, I believe PNG is the default style. So yeah, save the current figure. All right. So I think a congratulations is in order. You've made it to the end of the Matplotlib section. We've come a very long way, right from the top. If we go right back up, let's see, far out, we've covered a lot here. You've created, from creating an empty plot to making a full-blown subplot with customization from a data set that we've manipulated. So that's a big step if you've been following along. If everything seems a little confusing at the moment, don't worry. This kind of work takes a little bit of practice, a little bit of going through, getting used to, a little bit of rewriting code, a little bit of making mistakes and making errors. But don't forget, the best way to learn is to play around and practice on your own. As a start, maybe you could make a data frame with a Numpy array and then start creating some plots of your own and just get as creative as you can, right? Try a different style, try different data. Really, the sky is the limit. In the meantime, take a little break if you need, and I'll see you in the next section.